This is the solution to Chapter 13 video assignment 1. The question states the equilibrium constant Kc for the reaction A plus B equals AB is 3.0 at our temperature. Consider the volume to be 1. Does the situation depicted in the figure below correspond to the equilibrium? If not, in what direction will the reaction proceed in order to attain equilibrium? So I recreated the situation right here on the board, and I just kind of wrote up some information for us. So I tallied the number of red that we have, which is 18, the number of blue which we have, which is 24, and the number of red-blue combos, which is 10. And I just have the volume here, we know is 1, the balance equation here, and I wrote out the equilibrium equation for the equilibrium constant. Right, since it's just simple stoichiometric coefficients of 1, it's just concentration AB over concentration A times concentration B is equal to 3.0. So the question is asking, is this depicted here, is this equilibrium? And even just looking at it before doing any math or anything, we can reasonably assume that the answer is no. Right, the number of reactants far outweighs the number of products that we see, and we know that if this number is greater than 1 and the higher it gets, the more the reaction will favor products. So since the products are so few in comparison to the reactants, we can, without even doing math, assume, hey, this isn't an equilibrium. But we will do the math. So to be able to solve this, really we just solve for the reaction coefficient, which is basically just taking the concentrations where you're at, seeing what that is and how that compares to the equilibrium coefficient. So QC equals, we know volume is 1, right? So if everything's divided by 1, the volume is 1, we can just kind of disregard volume for this situation here. So QC is 10, which is our number of ABs there, divided by 18, which is the concentration of red, times 24, which is the concentration of blue. And that yields an answer of 0.023, which is, as expected, far from 3.0. So see here that QC is less than KC. So if we have a bunch more reactants than we do products, to reach equilibrium, we're going to have to go right along this equation here. So A and B will react, they'll collide, they'll react to form more AB until it is that the concentration of AB is such that it is 3.0 ratio of concentration product to concentration of this product of the reactants.